Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Gagan.
Hi.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, but just like last week, we are not broadcasting from our usual home, astronomy.fm, and instead this time we are broadcasting directly from our YouTube channel. The York Universe broadcast runs every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal time. The York Universe production works in concert with our online public viewing system run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Also on our YouTube channel where we are now broadcasting. So make sure to stay tuned for some nice, beautiful images of space taken by our observatory team, including images from our 1-meter telescope. This broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy, who again is not running our broadcast for us tonight. For any questions or comments you have about our past shows, or if you have comments for future topics, please send us an email at observe@yorku.ca. And remember that you can connect with us on Twitter at our handle @YorkObservatory, on Instagram with the handle @YorkUobservatory, and on Facebook at Allan I. Carswell Obs. You can also always visit our website at yorku.ca/science/observatory to hear about the fun things happening at the observatory, including our teletubes, any in-person visits, and of course, the wonderful OPV and York Universe combination on Monday nights. All of our programs are free, but if you would like to make a donation, again, please visit our website at yorku.ca/science/observatory. We will be monitoring the chat room for questions and to post any content, so make sure to keep an eye on that as well while you're on our OPV broadcast. Well, how are you doing tonight, Gagan?
Pretty well. Kind of a long day, but that's research.
Yeah. Definitely rewarding though, long days of research.
Yeah, no, they're definitely, you feel fulfilled at the end if everything goes well, provided that. Sometimes you feel empty inside, but it's all part of science.
Yeah, I know the feeling. Yeah, for me, the empty feeling inside is always when Python decides it doesn't want to cooperate with me. So I'm sure you have some similar feelings for your experiments.
Yeah, not computer related. Actually, sometimes it's just that some of the computers that we have doing our microscopic imaging and imaging of other stuff is like they're probably several decades old. So sometimes they're frustrating. They run pretty simple programs, but they don't work. Sometimes my problems are more, I guess, tangible than Python malfunctioning. My problems are like, oh, my fish didn't breathe this morning. So I have something to be mad at.
Yeah. I know when you get a computers working with a system, you never update them, you never change the software, hardware, anything. It's working, so you leave it, and then it gets frustrating later.
Oh yeah, we have one computer that's in one of our shared lab rooms, and a few days ago, I wanted to get an old file that I worked on probably a year ago off of that computer. And I accidentally clicked sort by date descending.
Oh.
And I had to turn off the computer because it started ordering files from like 2004. And I'm talking thousands and thousands of files. The whole program crashed. It was kind of a mess. This is the first time I'm telling anybody I did that, because I just turned off the computer and turned it on again and didn't tell anybody that I maybe broke it. So don't tell my lab. Anybody who's listening to this, don't tell my lab that there's a computer that I may or may not have ruined. But it's not my fault that we haven't updated that computer or exported any of that since 2004, because as far as I'm concerned, I don't think there's a hard drive attached to it. I think if you lose the computer, you lose the whole thing. It's not connected to Wi-Fi. It only runs on Internet Explorer, which also doesn't work because there's no Wi-Fi or Ethernet. And I'm not even sure the software or the hardware that it is attached to is even like real. I think it might be a scam, but I'm gonna leave it at that.
Oh, it runs the equipment, so that's all that matters.
That's true. Yeah, yeah. It'll spit out a number. Is the number right? I don't know that either. But it does the job.
Yeah. I'm pretty sure once we get all the observatory systems up and running, it will be like this is never being updated and never being changed ever again.
Oh
So
no, I mean, I honestly can't believe we're updating everything now because for the first probably 4 or 5 years that I was at the observatory, well, that we were at the observatory, it was like, yeah, yes, we're running a program that was designed in the late 90s. Will we change it? No. Which we did end up changing. That was a shocker.
yeah, but we had to get new domes for that change. I'm pretty sure if we still had the old dome, we'd be on the exact same dome tracker system that oh man, that I have a lot of memories of
Like a
dome tracker.
manually written dome tracker code that was for our own observatory and nobody else's.
Yeah, yeah.
I mean, hey, we were coming up to the observatory to manually close the domes at like 2 in the morning, almost every night
Mm-hmm.
prior to that. So good for computers.
Oh yeah. Oh yeah. Well, I
Is
think
Milky Way still in there?
Milky Way is, but it's not controlling the 1 meter anymore. So it's
Milky Way's not.
sorry?
Sorry, I was just shocked. Who's controlling the 1 meter if it's not Milky Way?
It's a new computer that's now just being called the 1 meter computer. But
Oh my God.
I'm really bad about messing up Milky Way versus 1 meter computer. And sometimes I say Milky Way when I mean 1 meter computer.
Can
So
we call this one Matt Damon?
that would be funny.
Okay, Matt Damon, but okay. Alternate name proposal, Andromeda. I feel
Oh,
like it'd be a good one.
that'd be a good one. That'd be a good one too. Yeah. Yeah. We got to come up with names for all of because there's 4 computers in there now. So we have to come up with 4 different new computer names.
Okay, I have an idea. You have Milky Way, you have Andromeda, and then the other 2 are going to be small and large Magellanic Clouds.
That is really good. I like that. I support that idea. I support that. Idea.
I would like credit when that's published.
Yes. And
okay, yeah,
it's recorded here live on York Universe, so
you heard it here first, folks.
Definitely get credit for that. But I'm sure we could both complain for very long periods of time about ancient computers that don't function properly or barely do what they're supposed to do. But we should probably get to this week in space and astronomy history, right?
Let's do it.
Okay, so I'm up first for space and astronomy history tonight. And the anniversary that we are, I guess we could say celebrating, is September 1st all the way back in 1859, which is the anniversary of the Carrington Event, the largest and strongest solar storm that has ever been recorded by human beings. So although the anniversary of the Carrington Event, and I'll get into a little bit more detail about what that is in a second, before we start talking about that, though, we have to go a couple days back to today's date, actually, August 28th, 29th, 1859. So around this time, there was astronomer Richard Carrington, who the event was eventually named after, who was observing the sun. He actually took really detailed drawings and records of what was happening on the sun's photosphere. And he noticed this collection of several different sunspots on the sun. So these sunspots are basically, they look like these little dots on the sun, these little black dots. They are not little, they're actually the size of planets, usually bigger than the size of the Earth, but they just look like dots because the sun is so big. So he was recording the presence of these sunspots on the sun. And they were creating a lot of, I guess you could say, chaos on the sun's photosphere, which is just because of what causes sunspots. They're basically areas where the sun's magnetic field gets sort of twisted up with itself. So you can think of the sun's magnetic field as having these magnetic field lines. And as the sun rotates and stuff in the sun kind of moves around, those magnetic field lines can get pushed around a bit and sort of tangle up with each other and create these, I guess you could call them knots near the photosphere that have a very, very, very strong magnetic field. And that kind of traps material there, makes the material cool down because it has no way of heating up when it's trapped at the photosphere. But eventually those magnetic field lines will get way too tangled up and snap. And when they snap around these sunspots, they create something called solar flares or coronal mass ejections, just abbreviated as a CME, where they release a ton of material from the surface of the sun, including photons and charged plasma, into space. This can eventually reach the Earth and cause something called a geomagnetic storm, where those charged particles interact with the Earth's own magnetic field and can do things like create aurorae and stuff like that on the Earth. So what happened on August 28th, 29th, around that period, is a collection of sunspots that Richard Carrington had been observing sort of twisted up and let out a powerful solar flare and a coronal mass ejection. Over the next couple days, these events, all of that stuff, hurled out into space and actually ended up hitting the Earth, which caused a powerful geomagnetic storm. Really powerful aurorae appeared on the Earth that could be seen all the way down quite far south, even down into Toronto, which any Torontonians will know aurorae that come that far south are pretty rare. So it would have definitely been a nice sight for anyone who was alive at the time looking for aurorae. But then on September 1st, something even worse happened, which is that these little sunspots led to a really massive coronal mass ejection. And this was the Carrington Event, the most powerful coronal mass ejection from the sun that has ever been recorded. Not only that, but it was able to be recorded partly because this material ended up hitting the Earth. And it did a lot more than cause aurorae when this happened. So of course it did cause aurorae, just like all geomagnetic storms do, but these aurorae were significantly more powerful than any other aurorae that had been observed. You could see them very far south, clearly see them down into as far south as Mexico. You could even see them in places close to the equator like Colombia. But it also caused a lot of chaos on top of making really pretty aurorae. At the time in 1859, there were telegraph networks. And when the charged particles from the coronal mass ejection hit those telegraph networks, it actually caused a lot of them to fail. It even provided electrical shocks to the telegraph operators and was even able to start fires around some telegraph lines that were in populated areas. So it definitely was a bit of a chaotic event for people on Earth. Now, the Carrington Event, the reason why it's such a big thing in history is because for a couple of different reasons. So first of all, this was the first time that any human alive had witnessed and recorded any sort of activity from the sun. So Richard Carrington observed this. He actually observed a flash of light come from the sun around the time the coronal mass ejection happened. But another astronomer, Richard Hodgson, was also independently observing the sun at the time and also recorded this coronal mass ejection. So this led to the event also being named after Richard Carrington, and even led to a new classification of coronal mass ejection called Carrington level coronal mass ejections. Now, the reason this was named after Richard Carrington and not Richard Hodgson, I believe, is because Richard Carrington became the first person to actually link geomagnetic storms and geomagnetic activity with things that were happening on the sun. So people had been observing things like sunspots for quite a while and had also been observing geomagnetic activity for quite a while, but no one was really ever able to make that link between what's happening on the sun and these aurorae and other things that happen in geomagnetic storms. But Richard Carrington was able to make that link. So it's kind of an important event for astronomy in a kind of historical perspective, because that was a really major breakthrough, that connection that he was able to make. But it was really important in another sense, in that it demonstrated how hard the sun can make life for us. So the sun provides us energy and life, which is obviously great. But when we get hit with things like coronal mass ejections, it can also cause a lot of issues. So in 1859, this was in the form of disturbing the telegraph networks. But if something like this, a Carrington level event, were to happen to us today, it would cause trillions of dollars worth of damage in the United States alone. So that's never mind what's going on in the rest of the world, which would, in the form of basically wiping out power grids. So it could cause blackouts globally for weeks, possibly even out to months, depending on how bad the damage is and depending on what area you're in. So the Carrington event, even though it happened many, many years ago, is just sort of a demonstration to us of, we do need to pay attention to the sun and what the sun is doing so we can kind of protect ourselves from any possible terrible geomagnetic storms caused by these coronal mass ejections. And interestingly, we had a near miss in 2012 where there was a Carrington level event, coronal mass ejection from the sun that barely missed the Earth. So it is still very, very possible. It can happen again. Thankfully, it's estimated based off of, interestingly, measurements of carbon-14 rings in trees, that the last time the Earth got hit by a Carrington level event was in 774 CE. So typically they happen to hit Earth only once every few thousand years. So yeah, very rare, but still kind of scary to think about what would happen if something like that were to happen today, especially considering we are approaching solar maximum, where the sun peaks its activity. It's this 11-year cycle where the sun goes from peak activity to minimum activity. And we are approaching that solar maximum where it is kind of a real possibility that the sun could have a Carrington level coronal mass ejection that hits the Earth. A little bit scary, but still pretty interesting, I think.
Yeah, that is, it's incredible that you can track them using the carbon-14 and the tree rings.
Yeah, I was so shocked when I read that. I'm not really sure what they did because I wasn't able to read into it too much, but it's really like crazy.
Yeah, it's like carbon dating basically.
Yeah.
So that's pretty cool.
Oh yeah, I definitely need to read up more about how they did that because I wonder who got the idea to do that.
I'm not sure how carbon dating, so you know how carbon dating is like useless now for everything since I think the 1940s, you can't use it anymore.
Really?
And it's because of the nuclear bombs in Japan.
Oh, wow.
Basically, they ruined carbon dating for everyone. So archaeologists can't use carbon dating on anything more recent than those bombings because the heavy isotope levels in basically every object has gone up like dramatically since then because of the nuclear fallout.
Oh man.
But so I mean, I don't know how that would impact carbon dating for tree rings since then. Like, would that show up as a solar flare, like a Carrington level event?
Mm-hmm.
So I don't know how we would. I hope we can still do it going forward.
Yeah, that'd be cool.
Yeah, but no, very cool. It does scare me though. We have, natural disasters abound already. We don't really need such a huge Earth scale one like this, not anytime soon. So I hope they hold off or extends it in other directions.
Yeah.
Uninhabited planets and the like.
Yeah, at least we have there's a lot more monitoring now than was happening in the last one during the Carrington event, because we have satellites like the Solar Dynamics Observatory that could potentially see it coming. So I'm not sure if any governments have plans in place on how to deal with a possible Carrington level event if it were to happen, but there is at least a monitoring system in place now. So it wouldn't just be like disaster all of a sudden. There would be a warning.
Do you think if there was like a total shutdown of the electrical grid, like an enforced blackout prior to the event, it would prevent that blackout from being so catastrophic?
I have no idea. I really don't know enough about, I guess it's electrical engineering.
Yeah, that's true.
So if there's anyone who knows the answer to this in the listening now, please put the answer in our YouTube chat and educate us all on
Yeah,
what.
please.
But I don't know what the fixes would be or what possible solutions or prevention. I can't talk today. Preventative mechanisms we could put in place for that. But yeah, I guess it theoretically is possible because we could see it coming.
Yeah, interesting. Hopefully we can. I'm gonna go take a look at that tonight. Probably get down to like a Google rabbit hole.
Yeah, but I think we've spent enough time talking about possible catastrophic scenarios where, you know, we lose power for a year. So how about you take us to more, I guess, happier news or happier history items?
Happier news, better times when electricity wasn't such a huge thing. So I'm going to take us back all the way to 1789. And this is when William Herschel discovered Enceladus. So Enceladus is one of Saturn's major moons. It's the sixth largest, and it was not one of the first ones to be discovered. And this is because it's really close to the rings and it's close to the inner, it orbits Saturn pretty closely. So it's difficult to observe. There were several moons that had been discovered prior to Enceladus. But on August 28th, 1789, William Herschel was observing Saturn at the Great 40-Foot Telescope at the Observatory House in England, which is an observatory that he founded with his wife. And he was observing Saturn during a Saturnian equinox, which is when Saturn's massive ring system is actually facing Earth, kind of edge on. So the rings don't block our view at all. We kind of are looking directly at the rings from the side, so we see them on a flat plane. And they don't impede our vision of what else is orbiting the planet. So most of the discoveries of Saturn's moons prior to Enceladus, which actually were made as early as the more recent ones were in the 1600s prior to Enceladus. So they were all made during equinox observations because it's really easy to see everything orbiting Saturn because the rings aren't in the way. So Enceladus is actually one of the most interesting moons in the solar system. I wanted to talk about this a little bit because we didn't really get a much closer look at Enceladus until the Voyager missions in the 1900s, but lots has been discovered since then. It's almost entirely covered in ice, and because of this, it has an extremely reflective surface. So it's got a super high albedo, and it doesn't absorb much light because of this. So the daytime high temperature, so at the hottest point of the day, hot is relative because it only gets to about minus 200 degrees Celsius on the surface of Enceladus. So it's super cold there all the time, and it gets way colder than that at nights. And the South Pole actually has cryovolcanoes that shoot plumes of ice and water and gases into space. And a lot of this debris actually leaves Enceladus and makes up Saturn's E-ring. So that's where a lot of that ring's substance comes from. Some other observations by Cassini during a flyby also point towards Enceladus having a huge subsurface ocean that's like almost 10 kilometers deep. And this has been corroborated with mathematical models. And this has been a very interesting target for future research, which I'll actually come back to during our news segment later on.
Yeah, this is definitely more relaxing to hear about than the Carrington Event.
Yeah, a faraway moon. I don't have to worry about how cold it is.
Yeah. Yeah, it's I enjoyed the bit about the who was it who founded William Herschel founding the observatory house in England.
Yeah.
That's a great 40-foot telescope. Wow.
Yeah, I say 40-foot telescope. That's not the diameter of the mirror. That's actually it was a reflecting telescope. That's like the length of the tube.
Oh, okay.
I believe it was 1.2 meters.
Okay.
In primary mirror diameter. So not that much smaller, not that much bigger than what we have right now.
Yeah.
A lot bigger in terms of like the overall size of the telescope. If you look up a picture, there's some drawings of it. It looks like a medieval cannon. So
yeah, a lot of old telescopes I think look a little funky. But that's why we love them.
Yeah, it was a big guy. It was, yeah, so 120 centimeter primary mirror and a 40-foot long focal length. So the focal length is the telescope.
Yeah.
But
Yeah. But
yeah,
I know Saturn looks amazing through the 1 meter. So it would definitely look just as good through a 1.2 meter telescope. We should try.
100%.
Yeah, we should. I don't think we Saturnian equinox. I'm not sure what the like the angle closest to equinox that we get for Saturn. But we should try. We could also try and spot it from the observatory telescope on
Oh,
when
totally.
Saturn is approaching equinox. Um,
Okay, so the next equinox is going to be May 6th, 2025.
oh, that's
So I guess it's a 15-year cycle
yeah.
between equinoxes.
So that's not bad. We could theoretically try and do that in the near-ish future with the 1 meter.
Oh yeah. Yeah, that's totally doable. So, okay, I'll put it in my calendar. May 6th, we have to be at the observatory. I guess anywhere in and around that period, we'll be able to see Saturn pretty well. And I believe we see Saturn on the horizon on the west horizon in May-ish. Am I right about that?
I'm really not sure.
Okay. Well, I mean, we'll figure it out when we need to.
Yeah.
But yeah, no, Saturn, hands down, one of the best things to observe in the 1 meter. And actually, I want to say the first thing I observed when we installed the 1 meter telescope at York,
Oh man.
that was like the first thing because it was end August.
Yeah.
So Saturn and Jupiter are both really nice.
Yeah.
Yeah, that was that time. It was really great. That was a really great time.
Yeah. I definitely remember doing Saturn observing on one of the first public tours with the telescope. Um,
Yeah, and it's just the best thing because you don't need the camera to see it well at all. You can see it with the naked eye very clearly. Even
yeah.
the Cassini division.
Oh yeah.
Yeah,
I think honestly planets like Jupiter and Saturn are even better observed through the eyepiece than with the cameras.
I agree.
You can see this, like you can see everything. You can see the planet, the rings, the
Moons.
moons, everything at the same time. But when you do the cameras, you have to play games with the exposure time so you can see the rings and then or the rings and the disk in the case of Saturn, and then a different exposure time for the moons. So I think these are
Yeah.
one of the few things that are actually better observed with an eyepiece than with the camera.
Oh, yeah, because you have to really overexpose Saturn to get all the moons,
Yeah.
but through the eyepiece, they're all clear. They're beautiful.
Oh yeah. Everything is beautiful through that telescope anyway.
Yeah. I think you're sticking around with Saturn for our next This Week in History.
Yep, yep. So September 1st, another September 1st event, but this time in 1979, so much more recent history, which is the anniversary of the Pioneer 11 Saturn flyby. So Pioneer 11 was like a twin spacecraft basically to the Pioneer 10 mission, who were both the first spacecraft to travel into the outer solar system beyond the asteroid belt and actually visit some of the gas giants in the outer solar system. So they were the precursor missions or the support missions to Voyager 1 and 2. They were going to take advantage of this very rare planetary alignment that happens every 175 years to basically do flybys of, in the case of Voyager 1, Jupiter and Saturn, and in the case of Voyager 2, all four of the gas giants in the outer solar system. The thing is that back in the 1970s, nobody had actually sent space probes that far out into space. So NASA decided to send Voyager 10 and 11 out there to not only kind of scope things out, do a bit of early science on the planets that would be helpful for the Voyager missions, but also to test out some of the maneuvers, including if you can pass the asteroid belt and get into the outer solar system, and also some of the gravitational slingshot methods that the Voyagers 1 and 2 would be using in their mission. So Pioneer 11 in particular was a very, very successful mission. It operated for 22 years in total and was one of the first objects to leave our solar system, one of the first man-made objects to leave our solar system. But for what we're talking about particularly here today is September 1st, 1979, when it did its flyby of Saturn. after it used Jupiter as a gravitational slingshot to bring it out to Saturn. So on September 1st, 1979, Pioneer 11 came within 13,000 miles of the cloud tops of Saturn and sent back a whole bunch of data, including 440 images of the planet, its ring system, and its moons. So just among some of the discoveries that it made at Saturn, and keep in mind that Pioneer 11, again, was the first spacecraft to actually go out and make these close-up observations of Saturn. So it really was a lot of groundbreaking science that this mission did. Among the things that it did is it discovered it, or it kind of confirmed that Saturn did have a strong magnetic field, which is something that had been suspected by astronomers. It also confirmed that Saturn is mostly made up of liquid hydrogen. It found 2 new moons and a new ring in the Saturn system, and observed Titan, showing it to be a very cold orange ball in space. So we know now that if you look at Titan with different wavelengths of light, I think primarily in the infrared, you can see through this hazy atmosphere. But in visible light, which was what Pioneer 11 was using, it just kind of looks like a fuzzy orange ball in the sky. So yeah, that's kind of a short and sweet news item here, or sorry, history item here of Pioneer 11's Saturn flyby.
Yeah, there's all the early planetary missions were just such great contributions to planetary science. I think planetary science is pretty much our theme for today, but yeah, we just like Pioneer 11's first flybys. I can't believe we were doing this in the 70s.
Yeah.
I say as if I had anything to do with it.
Yeah, it's just like, I don't know, I agree with you on that. It's really remarkable what a lot of the early planetary missions were able to do. Pioneer 11 definitely a really amazing mission, especially because it operated for so long. I mean, most of these missions were not really intended to operate for that long, but they were working. So why not keep taking data as it travels further and further out into the solar system?
Yeah. And we just retained contact with Voyager 2.
Yeah.
So
didn't somebody mess up and that's why we lost contact with Voyager 2?
did somebody I thought it was like it went behind something. I'm not 100% sure, but then it managed to reset its satellite on its own.
So from the New York Times, the space agency lost contact with Voyager 2 on July 21st when the mission team accidentally set a command that pushed the spacecraft's antenna 2 degrees away from Earth.
Yikes. I would hate to be that person
Oh yeah.
in SATCOM. That is I think I would like cry in the bathroom for
Oh yeah.
days, months. I don't know.
It sounds like a stupid mistake that something I would do.
Oh, that's such a small mistake too.
Yeah. So this is
Catastrophic
partly why I like Python, is that if I make a mistake in Python, it doesn't really matter. My code will just crash. So
Yeah, it doesn't run away with millions of dollars of government funding.
yeah. But at least they got contact back. The system,
Yeah.
so many kind of, I guess, dummy-proof systems installed in the spacecraft, so it was able to regain contact.
I hope that person sent out like a team-wide email the day they regained contact and they were like, "See, it's all fine. Nothing's wrong. You don't have to fire me."
Yeah. Yeah, we are approaching the halfway point here. So you have one last this week in history item for us. So why don't you take that away?
Awesome. Yeah, this will be a quick one. So we've got a birthday shout out tomorrow, not today, but this week. So August 29th, 1959 is the birthday of our very own Chris Hadfield. So Chris Hadfield, as you might know, is one of the most accomplished Canadian astronauts. He was born in Sarnia, Ontario, and he grew up in and around Southern Ontario, which is where York University is located. And he was really inspired by the moon landings as a kid. He earned his pilot's license early on as a cadet, and he joined the Royal Canadian Air Force. Later on, he did a degree in engineering at Royal Military College in Kingston. And then in 1992, he was accepted by the Canadian Space Agency into the Canadian Astronaut Program and thus began a prolific career in space. He flew 3 separate missions, 2 space shuttle missions that were part of the ISS construction process, as well as 1 trip aboard the ISS. So on the shuttle missions he was part of the groups that installed and first used the Canadian Canadarm systems. So that's the big robotic arm on the ISS that catches satellites and land air and dockers and stuff like that. So really important part of the ISS. And on his 3rd mission to the ISS, he actually did a stint as a commander of the ISS crew, and he actually retired upon his return home from that mission. So he's had a remarkable record of spaceflight. During one of the shuttle missions for the Canadarm, he was also the first Canadian astronaut to leave the spacecraft and spend time untethered in space. So he was, free floating during his spacewalk, and he spent over 14 hours in space across 2 different spacewalks to perform maintenance and construction on the Canadarms. He also has many other talents besides spacewalking, in case these kind of get left unmentioned, but he's a very accomplished musician and author, and he has published 5 books, one of which is an autobiography, which was An Astronaut's Guide to Life on Earth, and he's also dabbled in fiction. A couple years ago, he had a book called The Apollo Murders, and his upcoming novel is called The Defector. They're both space thrillers. So I heard The Apollo Murders is really good. I have a copy sitting on my bookshelf right now, but I just haven't gotten to it. But he's doing great. And he was also a professor at Waterloo, an engineering professor, for a few years in the 2010s. So yeah, very accomplished individual.
Yeah, it's just kind of silly, but even though Chris Hadfield has done so many amazing things and has so many accomplishments, the thing that I always think of when I think of Chris Hadfield is the guitar in space.
And 100%.
Guitar in space.
The guitar, and then he just tweeting photos from the ISS all the time. It was great.
Oh, yeah.
Yeah, definitely missed those.
Oh, yeah. Yeah, I love following astronauts on Instagram and stuff because they just post so many cool pictures of the ISS and the Earth and space. Really, it's always fun to watch. Fun to see.
So many. He actually has another book, I think, that's just pictures from the ISS.
I would definitely buy a book with pictures from the ISS. That would be really cool.
Right? Like that's my coffee table book. I'm not changing that.
Yeah.
All right. So I think we're over halftime, as we normally are. Yeah. But we have some reminders for you. If you joined after we started earlier, you're listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Tonight, you're listening to Senna and myself, Guggen, and we're discussing all things planetary science, as well as a little other stuff. We just finished up with This Week in Astronomy History, and we are about to start our news items. Make sure to keep an eye on the OPV chat on our YouTube for some astronomy images, as well as to chat with other members of the observatory crew. We'll be monitoring the chat room for questions and comments. Just a reminder that we have no show next week, as it is a holiday, Labor Day in Canada. And I believe Senna has another reminder for you.
Yeah, so this reminder is, I guess, part news item and part reminder, which is that a couple of days ago, NASA's Crew 7 mission, collaborating with SpaceX, brought 4 astronauts to the International Space Station, which means that it's also time for the previous set of astronauts, the Crew 6 astronauts, to return to the Earth. They're scheduled to do that on September 2nd. The hatch closure is happening at around 7 a.m. So the 4 Crew 6 astronauts are going to go into their Crew Dragon spacecraft closed the hatch at around 7 a.m. and should be splashing down off of the coast of Florida at around noon. So definitely keep an eye out for that. I always love watching the launches and splashdowns of the crew space program. I always think they're pretty interesting. So if you're looking for something to watch, that will be broadcasted live on NASA TV and also probably on the SpaceX YouTube channel as well.
Awesome. Yeah, we always love seeing the crew return and launch missions.
Mhm.
Yeah, okay. So, Sana, I think you're up first with our news item.
Yeah, so this is more solar system stuff, as with everything that we have been talking about today unintentionally. And this is a really, really exciting piece of news because the Indian Space Research Organization, or ISRO, which is India's space organization, recently landed on the south pole of the moon. So they landed their Chandrayaan-3 spacecraft on August 23rd near the south pole of the moon, which not only makes them the first spacecraft to land near the south pole of the moon, but makes them only the fourth nation ever to land anywhere on the moon, apart from the Soviet Union, the United States, and China. So the landing, this was a soft landing, so they were actually able to nicely place the spacecraft on the surface of the moon so that it can continue functioning, as opposed to a hard landing where a spacecraft literally just crashes into the moon. A controlled crash nonetheless, but still a crash. So the soft landing took place using their Vikram lander. And I think it was the next day after this soft landing on the 23rd, they also deployed a rover named, I'm going to completely butcher this name, so I'm sorry about that, Pragyan, I think is how you say it. And this rover is going to spend the next 2 weeks or so roving around the lunar south pole, studying the chemical composition of the soil and the general lunar environment around the South Pole. So this is definitely a really, really exciting mission, not just because of all of those firsts that the ISRO has been able to accomplish with the Chandrayaan-3 mission, but also because of the really cool science that can be done in the South Pole. So if you've been paying any attention to lunar exploration stuff the past couple of years, you might notice that there has been a lot of excitement about sending probes to the South Pole of the moon. So China has plans in 2026 to send a rover there, Tranche 7. NASA plans to send their Viper rover in 2024, the Volatiles Investigating Polar Exploration rover. And Artemis 3 even has plans to land astronauts in the South Pole when the Artemis 3 mission flies in probably a few years' time, but maybe a little bit longer than that. The ISRO had even gotten itself into a new sort of space race with Russia, which had been aiming to land a spacecraft in the South Pole of the moon a couple of days prior to Chandrayaan-3. But that spacecraft, Luna 25, ended up crashing into the moon. So Russia was not successful at beating India to the moon. And Chandrayaan-3 is the one that actually holds that record for being the first country and the first spacecraft to actually land near the South Pole. Now, the reason that so many space agencies have been wanting to go to the South Pole is just because of what you can find there. So the South Pole does not get a lot of sunlight, and it has a lot of craters that can make what are called these permanently shaded regions. So these are areas of the moon that never get any kind of sunlight. And these areas are really good at harboring water ice. So a few years ago, another Indian mission, ISRO mission, Chandrayaan-1, which was a lunar orbiter, found what were consistent with signatures of water ice coming from the lunar South Pole. And it found a ton of water in the lunar South Pole. These results were then confirmed a little while later by NASA's SOFIA telescope, which I was about to say spacecraft, but it's not a spacecraft. It was a big telescope that was actually installed on a modified Boeing 747. So SOFIA would fly above the atmosphere and be able to take these great infrared observations of the night sky and the moon. So SOFIA and Chandrayaan-1 kind of worked together to be able to discover water ice on the South Pole of the moon. And estimates based off of Chandrayaan-1 and SOFIA observations say that the south pole of the moon might contain 600 million tons of water ice. And this is a low end estimate too, so it could be much, much more than that. And all of this water ice exists in these permanently shaded regions that never get any sunlight. So what happens is that this water ice will sort of make its way into this permanently shaded region. It'll freeze and eventually sort of be absorbed or sink into the lunar soil in that area, where it stays put because there is really nothing, so there's no sunlight to evaporate that and cause that to, not exist on the moon anymore. So there could potentially be tons of water ice that's stored in this south pole region of the moon, which can be very, very useful for any future missions to the moon. This includes possibly unmanned missions, but also would be super helpful to manned missions, because humans can if we can find a way to basically get this water out of the lunar soil, we can use that on manned missions for things like drinking water, for things like coolant on space experiments and vehicles. It can even be modified to be used as rocket fuel and split up into the hydrogen and oxygen atoms in the molecule to be used for breathable air. So it's a really important resource in terms of sustainability in space, because you can kind of imagine an idea of, instead of launching astronauts with a whole bunch of resources like fuel and water, you can give them a little bit of that, launch them into space, which is a lot more cost effective and a lot easier to do than launching them with a lot more resources, because that all adds weight to the mission and makes it harder to launch. You can launch them into space, go to the moon, manage to get water out of the soil in the south pole of the moon, and then use that water as resources, not only for them to live and work on the moon, but also potentially to launch from the moon after you have, gotten all of these great resources, this great water from the moon, and then head over to Mars, which again is a lot more cost effective and a lot easier to do than just launching astronauts directly from the Earth, just because the moon doesn't have as strong of a gravitational field. So there's a lot of interest in basically doing this and learning more about how much water is stored in the soil on the moon and how we can sort of take advantage of that. And I think that's one of the things that the Chandrayaan-3 mission is going to be able to do. It'll study that environment, help us learn where that water is, how much of it there is, and possibly ways that we can use that to our advantage in space travel. And this is especially exciting because even though the rocket launch, or the landing, happened on Wednesday last week, Chandrayaan-3 already has a science result. So the scientists were able to use data from the Chandra's Surface Thermophysical Experiment, abbreviated as CHASTE, to measure the temperature profile of the moon at different depths. Now, this is the first kind of measurement like that has ever been made at the lunar south pole. So it is an early science result, and there is a lot more data to come out of this, but it's still a really, really significant discovery, and just sort of sets the stage for what Chandrayaan-3 and its rover are going to be able to accomplish at the moon. So I think this is a really interesting mission, and we will learn a lot about the moon and possible applications of using water in the future. But before I stop talking about this, I also do want to mention how hard it is to actually land on the South Pole, which is another one of the reasons why this mission is so significant, is that, like I said, the South Pole has a lot of craters, and it's really hard to properly land a spacecraft when you have so many craters, because you have to be in this nice kind of flat terrain. So this is one of the reasons why it was so hard to get to the South Pole, is because you had to have a spacecraft that was able to avoid all of those different craters and the different stuff on the lunar surface, which Chandrayaan-3 was successfully able to do. Its rover, Pragyan, if I'm saying that correctly, has also been designed to be able to avoid craters, falling into craters on the moon. And even like only less than a week into the mission, it has successfully avoided its first crater. It was approaching a roughly 4-meter diameter crater on the surface, but kind of noticed it and was able to literally just back up and back away from the crater and take a different path on the moon. So this is a great mission, definitely off to a great start. And I really can't wait to hear some of the other science results that come out of Chandrayaan-3.
Yeah, that one's awesome. There's like we have a lot of plans for the moon in the next few years.
Mhm.
So this is definitely something that'll be a stepping stone, especially for the Artemis missions, because we do want to use the moon as a base for further travel elsewhere.
Mhm.
It'll be very useful if we can use, lunar resources instead of bringing our own, or even being able to establish a way to kind of use that to bump up our resource. Um, I don't know. We can use it as a backup, if not, our total water supply.
Yeah. Yeah. Yeah, the moon
Yeah.
is there's been so much attention on lunar exploration, which I'm really happy about. It's been too long since we've
Yeah.
last had humans around the moon. So
Yeah.
uh
I mean, this time in the 70s, they were canceling 2 more Apollo missions.
yeah,
So, that was one of our This Week in Space History candidates. Maybe you'll hear about it this year, next week, or sorry, this week, next year. Um, but yeah, I'm glad we have more attention on the moon. We recognize its possibilities for further, space travel afterwards.
mhm. Yeah, and also I'm so very happy that there's a Canadian astronaut on Artemis 2
Oh,
launching,
absolutely.
what is it, next year, or the year after that Artemis 2 is supposed to launch?
Is it 2024, I thought?
Okay, so yeah, 2024, that sounds about right. Um, so I was very, very shocked to hear that it was actually 3 Americans and a Canadian on that mission, but very pleasantly surprised that Canada will be the second nation to send a human to the moon.
Yeah, so it's expected November 2024, that's the planned launch date. Um, of course, things don't usually go perfectly, so probably late 2024, early 2025, within the next year and a half or so is when we expect Artemis 2 to be underway, and that's the crewed mission to the moon,
Yeah.
which I'm pretty sure they're not landing, they're just going around.
No, they're gonna be they're going farther away than any human ever has traveled. And I think they're literally just doing like a loop around the moon and coming back. I don't think they're going into lunar orbit.
Yeah, they're just doing a flyby. They're, like, slingshotting back around.
Okay. Okay, yeah, that makes
Yeah.
sense. But yeah.
Yeah.
Congratulations to the ISRO on Chandrayaan-3.
Yeah, beautiful mission.
Mhm.
All right, so for our very last story for this week, I'm sorry, guys, I do have to end the show off with some bad news. We have some more delays in the New Frontiers mission program. So NASA's New Frontiers program is a mission program that revolves around our understanding of the solar system. Thus far, we've had 3 New Frontiers missions: New Horizons, which was the infamous Pluto mission; Juno, which was a very successful probe that went to Jupiter; and OSIRIS-REx, which is an asteroid orbiter and a sample return mission that went to Bennu. In 2019, NASA announced that New Frontiers 4 would be Dragonfly, a helicopter/lander mission to Titan, which is Saturn's largest moon, and this is expected to launch in June of 2027. So I have to believe that the recent Ingenuity helicopter kind of played a part in this one, or at least this mission's decision played a part in Ingenuity really needing to be a success, because helicopters on other solar system bodies is not a very easy task. And this helicopter going to Titan is not going to have an accompanying lander. It is the lander and the helicopter all in one. So NASA's goal when it started New Frontiers was to announce 2 of these New Frontiers missions per decade. However, we've kind of slowed down on that expectation a little bit. So the call for proposals for New Frontiers 5, which was expected to be this year, has now been delayed. The announcement of opportunity, or AO, which is the call for proposals, was proposed for fall of 2023. In the next few months, and NASA released their preliminary draft and notes on the announcement in February, but progress has really slowed down over the summer. For starters, the Planetary Space Division is looking at a few budget cuts, and they don't expect to have the full 2024 budget that they've requested, and it's unlikely that they'll have the 2025 budget as well. So, of course, this put a damper on mission planning. It kind of restricts what the different teams can do. So, we're probably going to see some delays in Dragonfly because Dragonfly is a big mission that's going to be going to Titan, which is very far away. And we probably won't see many more announcements for missions until much later. So, the draft announcement of opportunity that was released in February, they asked for proposals for missions on 6 different topics, which was recommended by the Planetary Science Survey in 2011. So it's a very similar set of topics as the set of proposals that were requested for New Frontiers 5. Basically, they want to hear proposals on a comet surface sample return, a mission to Jupiter's volcanic moon Io, a mission to create a lunar geophysical network, a sample return mission to the moon's south pole, and a mission to characterize the habitability of Saturn's icy moon Enceladus, which I mentioned before in This Week in History, and a probe of Saturn's atmosphere. However, the draft AO, announcement of opportunity, has now been delayed for almost 3 years. They expect that this announcement of opportunity, which is expected to be released in, like I said, November 2023, is now not going to hit the science teams until earliest 2026. So we have a pretty big delay on these missions. That's not all a negative. Because there are changes to the timeline, we're also going to be seeing changes to the likely mission topics. So we might see a little bit of revisal or a few revisions made to the list of potential projects. And this will consequently allow more proposals to be submitted over the following years. So at least now science teams know what the outline of topics is, or the project goals are going to be. So they have a few years to set up their proposals. For context, there were 12 mission proposals that were reviewed for Dragonfly or New Frontiers 4 prior to Dragonfly selection. So Dragonfly was one of the proposals. So it sucks that we're getting more delays, and they all seem like really interesting missions. Like, I know we previously had the asteroid sample return, so now they're looking at a comet sample return, and we've already seen missions to Pluto and Jupiter. So now they're looking at Saturn, which of course is a really interesting moon system, as well as the moon. So I don't know. I think we will get a very exciting mission announcement after 2026, but it sucks that we have to wait.
At least nothing's canceled.
That's true. That's a positive, right? Because sometimes they're just like, by the way, we're not doing this anymore. Too much money.
Yeah. So at least nothing's canceled.
Yeah.
I also noticed here you said the decadal survey in 2011. So maybe they are modifying some of the mission plans for the recent decadal survey results. Because there was one, what was it, the 2022 decadal survey that happened?
Probably, yeah. I think that was around then. Yeah, so they're likely going to be making some changes. I think they had, basically for New Frontiers as a whole, they had a few mission outlines, which is basically increasing scientific knowledge on the different bodies of the solar system. So right now we've done asteroid and 2 planets.
Mm-hmm.
So I think we're going to be, especially because there's been so much focus on the moon, we might go there. But conversely, because there's already been everybody and their dog is going to the moon, basically. And maybe New Frontiers is like, let's do something else.
Yeah. Leave the sample return to Artemis and focus on something else for their plan.
Exactly.
I
mean, I would love to see Enceladus and Io.
Oh yeah.
I think either of those would be great missions, and I think they would be great missions, but I think they would heavily depend on Dragonfly's success.
Mm-hmm. That Dragonfly sounds really, really cool, though.
Oh, have you seen pictures? It's a straight up helicopter that they're just sticking on the moon, on Titan. Yeah, and it's gonna fly around.
Oh my God, yeah, that's such a cute little helicopter.
I know.
I mean, it's probably the size of a car, but
Yeah, it's gonna be pretty big.
I'm gonna call it the cute little helicopter because there is no good size reference when looking at simulated images of a helicopter on Titan, but
It's gonna be adorable, I'm sure of it.
oh yeah. Yeah, we can put it looks like there's room to put a little smiley face on it, so
If they don't, I'm gonna file a complaint to NASA. All right, looks like we're nearing the top of the hour. Well, everyone, you've been listening to York University Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana and myself, Guggen. You can always connect with us on Twitter at the handle at York Universe, Instagram at York U Observatory, and Facebook at Allan I Carswell Obs. Check out our website for show notes, content, updates, and contact info at www.yorku.ca/science/observatory. Thanks for tuning into York Universe, clear skies, and have a good night.
have a good night.